Hi, today I'm going to be looking at the assessment task which I've made for Skew boreholes. So as you see here, we have our boreholes drawn in already, and we're told that borehole A has an altitude of 65 meters, so it's up to there. Borehole B is altitude 90 meters, and that goes up to there. We're told that borehole A is going in a northwest direction of that way, and borehole B here is going in a southwest direction, and that the distance between borehole A and B is 60 meters north. So A down here and B up here. So you might ask yourself, how have we gotten this far already? How have we located the boreholes in plan and elevation? Well, first I'll show you how we done A. It's just a repeating of steps from there. So from A, we are given everything that you need to know to find these from the start. You're given the altitude of 65 meters. You're given the given inclination of 75 degrees to the horizontal plane. That's that green line there, and that's where you start. So from there, you draw the line 75 degrees down. You project this down to plan, where it meets the line straight across from A. And this is rotated back to the northwest line that's drawn from A. And where that intersects gives you the northwest borehole of A. And that's projected up to elevation, and where it hits the XY line is just drawn in. And that's how you find the boreholes in plan and elevation. And I'll just show you a 3D representation of how that's done in the model I've made here in SolidWorks. So here's our borehole A in the northwest line that's drawn for it. So if I just go to where the plane is, and I go normal to that, you can see here that's the 75-degree angle where it is drawn in the horizontal plane. That's the 65-meter height. So essentially what you're doing is this is an auxiliary view in at borehole A right now, and it's just getting that 75-degree angle of the horizontal plane and getting the altitude, and then that's done for both boreholes. And that's how it looks then in elevation. Perfect. So the next part is drawing in your head wall and your foot wall. You can see we already have 2 points here in borehole B for it. So there we have the foot wall point at 25 meters for borehole B and the head wall point at 80 meters for borehole B. I'm going to show you how that's found in plan. It's very simple. So we have all the points that we need in the question. They're given to us. So on A, we're given heights of 55 and 45 meters. So we just mark them off like so on that. And we also are given heights of 80 meters and 25 meters, as I said, in point A. So we're getting our points here. Project this across. We get it here then as well also, and they're dropped down to plan as well. And once they're all in plan, they can all just be joined up from head wall to head wall and foot wall to foot wall. And it's a very straightforward process. So that's what it looks like then once they're all joined up. So just hide those then, just keep it neat. And there's, again, this is done also in the 3D model here. So again, once all the points are marked off, we have them here as well on borehole A. They can simply be joined up using the 3D sketching tool. And here's a view of the stratum lines as they are moved all the way around. So now once these are found, the next step is to find our strike line. And it's one of the first parts of the first task that we're asked to get. So as you can see here at the top, we're asked to determine in part 1, determine the strike dip and thickness. We need to find the strike first before we can find the dip and the thickness. So exactly like it is in road geometry, what the strike essentially is a horizontal cut across the stratum. So if I just turn on the first step at here is just finding the level line. So we've done our horizontal cut here across the foot wall of A, and then what we need to do is from the foot wall of B, make a line parallel to our head wall to where that intersects. That gives us our strike in elevation. So then what we need to do is we need to project that down to plan. And this is just a simple re-repeating of steps. It's just drop down to the plan, and then it's done once again down there. So project it down to plan, and then from the footwall of B, again parallel to the head wall, it's drawn straight out to where it intersects, where it's projected down, and then from A, it's projected straight out, and that's our strike line then in A. So again, we have a 3D visualization of that. And again, it's just simply using this rollback feature to show it in a step-by-step format. So we'll show it first from the elevation, and we can see there's the horizontal cut that's brought across, and then here's the footwall line, or the strike line, sorry, being projected up from the footwall parallel with our head wall, and then the strike line is drawn in along that horizontal cutted plane then, and we can see there it is going out towards that way. So the next step, once we've found our strike, is to find our dip and our thickness. So how do we find that? Well, finding our dip and finding our thickness is very simple. Finding the dip and thickness is done by following a line along the strike and going perpendicular to that. Looking in perpendicular along the strike is how to find that. So seeing as we have the strike drawn in here, we need to keep looking along this. So we're going to bring all our points that we need, all the head wall and footwall points, along parallel with this, and look in and an auxiliary view in from that. So I'm just going to turn on my auxiliary view layers here. First of all, we'll make an X1, Y1. So we can start off that auxiliary view and then bring all the points up. Now we've got all the lines drawn in. So now what we need to do is we need to go 2 views back to our elevation view, take our heights of our head wall and our footwall, and project them onto these lines, the corresponding lines that were projected out here in this auxiliary view. And then that's done, and we are able to get our thickness then once all these are joined up. So as you can see here, we've got the line from our footwall of B, taking the height from here, and projected it onto the corresponding line that was projected out in the auxiliary. And the footwall line from A, the height is taken from here in the elevation, projected onto the strike line, which was the original auxiliary line, is drawn in, and that's the footwall of our stratum drawn in then. As we know, for our dip, it's the angle the stratum creates the horizontal plane. So that's our dip angle then in there, and our thickness is in there. So that's the first part of our question complete, and we can look at that in the 3D visualization as well. So we've got our strike line here, and again, finding dip and thickness is done by looking perpendicular along the strike. So we've got a perpendicular plane here, and if we go normal to that, which is looking along it, perpendicular, we've got our dip and our thickness there then. And the dip then is where the angle this line makes the horizontal plane. So I've got a roll back here for that as well. So our dip would be the angle it would make there. Now, that's our dip and our thickness found. The next part of the question then is we're asked to find the apparent dip of the stratum on a vertical section through A that trends in a southerly direction. So the apparent dip is it differs from the true dip in that it's not going to be looked at perpendicular along the strike. We're actually given the section where they want to look, and they want to look at it in a southerly direction. So we're not looking for the true angle of this. We're looking at it as though we were looking at it from a southerly direction. So the first thing we need to do is we're asked to do a southerly direction from A. So seeing as A is here, we need to draw a southerly line down from the bottom of that. So we'll just turn that on there. So there's our southerly line. Now what we then do is we take these points, project up from the auxiliary, parallel with these, so we can get the points from the dip in the thickness here. And we project another x1, y1 out parallel with our southerly line. So we turn on that x2, y2 there. Now we take the points that are intersecting with the dip in thickness, and we apply them to the two lines that we have projected up. So we have them all there. One of them is actually on the ground, so one of them is right here. Once we've got those in, we can simply draw those in. And that's the apparent dip we have in our southerly section. Now, so there's one final part that we have here up in the top right section, and it's using notes and sketches outline the difference between true dip and apparent dip. This will test not only the students' knowledge, but their understanding of the concepts which they've learned within Skew Boreholes. So it'll test how they, in this case, the difference between true dip and apparent dip. So going to turn on the notes that I've put in here. So from my understanding anyways, true dip is the true inclination of the stratum over the horizontal plane, and it's always found by looking perpendicular to the strike. Looking along the strike, So, and also I think apparent dip is when the angle between the cross section and the strike is anything less than 90 degrees, making it less than the true dip always. And the key difference between these is true dip can be seen as going straight up a mountain, and apparent dip can be seen as taking the mountain at an angle, making it less steep. That's where I think the key real life difference would be between true dip and apparent dip. That's how I kind of try and relate it to students and show them the key difference between. So that was my assessment question for Skew Boreholes. Thank you for watching, and see you again soon.